This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, we're continuing graphing trig functions, still working on the sine function here. And in this video, we're going to do this problem right here. So we need to find the period, the amplitude, and the phase shift, and then graph. So we're getting to a more complicated problem. The amplitude's pretty simple, this 1/3 up here. So that one's going to be simple, but we also need to state what the period is. And we need to, so let's do the amplitude. And we're going to have to do the phase shift. Okay, the amplitude's the easy one. That's 1/3 because that is the coefficient, right, in front of the sine. And of course, it's the absolute value. So if it was negative 1/3, the amplitude would still be 1/3. All right, now what about the period and the phase shift? Okay, the period you can always get by taking the coefficient of x, right? And that is your b. Okay, so to get the period, note b equals 2 because that comes from right here. All right? And so to get the period, we always do 2 pi over b. 2 pi over b. So in this case, that would be 2 pi over 2, which is pi units. So the period will be pi. It doesn't matter if something's added or subtracted to it, or if there's a parentheses next to the 2. It's the coefficient of x. That's what your value of b is. And instead of writing equal, I'm just going to put there. All right, so we've got a period of pi. Now what about the phase shift? All right, so if you remember from the problems where we were just doing problems with a phase shift, like y equals sine of 2x, what we did is we would take whatever is in the parentheses, the whole thing in the parentheses, and say how would we, what would that equal? What would x have to equal to make that 0? So basically, you take that and set it equal to 0. So for the phase shift, remember you're going to say 2x plus pi is equal to 0, and then solve for x. So if x was negative pi over 2, it would make what's in the parentheses, it would make the argument inside here 0. So the phase shift, well, the negative sign tells you it's going to the left. So this will be pi over 2 units to the left. I'm not going to write the word units just because I don't have a lot of space right here, but everything gets shifted pi over 2 units to the left. So we've got the period, the amplitude, and the phase shift. Now we're going to need to find our key points, starting with the x coordinates. So here's our equation. We know the period, the amplitude, and the phase shift. Well, what does this mean if the phase shift is pi over 2 to the left? Remember when we solved it, 2x plus pi equals 0, we ended up solving and getting negative pi over 2. This will be our first x coordinate because everything got shifted over pi over 2 units to the left, and so that is actually the first order pair we want. Instead of 0, we're moving to the left pi over 2, which is negative pi over 2. Now we need to get the rest of these, and I think I'm going to have to write this as like this to get it to fit. Okay, there we go. So then how would I get the next x-coordinate? Well, so if you start at negative pi over 2, and we've got a period of pi, remember, we need to add 1/4 of that period so that we're actually adding 1/4 of pi. So what is a way of thinking about it? Here's negative pi over 2, and you want to end up pi units, right? Whoops, sorry. You want to end up pi units to the right. So in other words, if I added pi to pi over 2, I would end up where I wanted. Okay. But I need to know these places in between. So I have to just first add 1/4 of pi, and then another 1/4 of pi, and then another 1/4 of pi, and then another 1/4 of pi. So that's what's going on here. I start out with my first x-coordinate, and I add 1/4 of pi. Okay, now to add these, I need to get a common denominator. So that would be negative pi over 2 plus pi over 4, right? So the common denominator is 2. So I need to multiply this first one by 2 over 2. So that's really negative 2 pi over 4 plus pi over 4. Yes, you have to be good at your fractions to do this. So negative 2 pi plus pi gives you a negative pi over 4 for your next coordinate. Now it's easier if all of your x-coordinates have the same denominator. So let's rewrite this negative pi over 2 with the same denominator, which is right here, right? So it'll be easier if we think of this as negative 2 pi over 4. All right, now, how much am I adding to get to the next place? I just add pi over 4 again. So if I added pi over 4. Here it is. That's what I'm adding. I'm always adding 1/4 of pi to get the next x-coordinate. So if I'm at negative pi over 4 and I add pi over 4 to that, what is negative pi over 4 plus pi over 4? I am now at 0. So that's my next coordinate. Now we're going to add pi over 4 to that. That would be pi over 4. And I'm going to add pi over 4 one more time. That is 2 pi over 4. And now the question is that a full pi units? So the question is, notice I started at negative 2 pi over 4, or you could think of that as negative pi over 2, right? And if the period is pi, you're adding pi, right? And so to add pi, you're really thinking it is 2 pi over 2. And that would give you negative pi plus 2 pi. Your final answer, you should end up at pi over 2, which is the same thing as 2 pi over 4. So hopefully that makes sense, that you would end up at 2 pi over 4, which is the same thing as pi over 2. So that's how we get our x-coordinates. Notice you just add pi over 4, add pi over 4, add pi over 4, add pi over 4, and that means if you just had added the entire period to the first x-coordinate, you should end up at this 5th x-coordinate, which is where the period ends. All right, now what about the y values? I think I'm going to make all this just slightly smaller because I'm running out of room. All right, so I rearranged the page a little bit so you can still see everything. Now, how about my new y values? I've got 1/3 the sine of this stuff. Well, remember, the reason we chose these values of x is because those will give us the usual values where we can, for x and sine x. And what really matters are these. Remember, it goes 0, 1, 0, -1, 0. So I just get to multiply 1/3 by all of these values. So I'll have 1/3 times something, right? All of these values get multiplied by 1/3. And so I'm multiplying by 0, then by 1, then by 0, then by -1, by 0. Of course, you don't have to show that step. You could do that in your head, but you do have to know these values over here. And remember, that's for the usual values we have for sine. And again, keep in mind, by using these values we have for the x coordinates here, it'll be the same after we plug in those values for x as just taking the sine of the x's you see here. It's a little confusing. Okay, so 1/3 of 0 is 0. Let me make those in purple. 1/3 of 0 is 0. 1/3 of 1 is 1/3. 1/3 of 0 is 0. 1/3 of -1 is -1/3, and 1/3 of 0 is 0. So these are our 5 ordered pairs that we're going to use to graph. So now that's our last step. By the way, it usually takes a whole page to do these problems because this is a pretty complicated problem. So we have to decide where to put our x-axis, the numeration system on each. Notice we're going from -2 pi over 4 to 2 pi over 4. So about the same to the left as to the right. So every 4 spaces is pi, right? Our increments are in fourths. So I've got 1, 2, 3, 4. That's where pi would be. 1, 2, 3, 4. That's where -pi would be. And what about on the y-axis? We're going in between -1/3 and 1/3. So how about just calling this 1/3? And we'll call that -1/3. If that bothers you, instead just go up and say there's 1. How about that? Yeah, that's not very consistent. Let's do it one more time. 1, 2, 3. Call that 1. Call that -1. All right, so we've got our markings. Being very carefully, we're very careful to mark these. So I have -2 pi over 4, 0. Okay, so that means I'm going over 2 spaces to the left for -2 pi over 4 and 0. And we've got -1 pi over 4, up 1/3. There's up 1/3. 0, 0. Pi over 4, -1/3. And 2 pi over 4, 0. And there we have, you can hopefully see the shape. Now if I keep going, I could also do these points, and there we go. Sketching our sine curve, and make sure we put arrows at the end. All right, so there we are. Y equals 1/3 sine of 2x plus pi. And as always, it's a good idea to plug one of these numbers in and make sure, like for instance, make sure that that really is a correct order pair by plugging in pi over 4 for x into here. So you know that y should be 1/3, so it's just a check. Y equals 1/3 of sine 2 times, what am I plugging in? X over 4 plus pi. And I'm going to actually do that computation. So that's 1/3 of sine what? All right, so this is 2x over 4, right? Which I'm going to write as x over 2. And getting a common denominator, I'm sorry, that was supposed to be pi over 4, not x over 4. Pi over 4. All right, so getting a common denominator, that's pi over 2. Plus, I'm getting a common denominator here and write that as 2 pi over 2. So that really gives me, keep on going, 1/3 sine of what? Well, you've got pi over 2 plus 2 pi over 2, that's 3 pi over 2. Oops. Three pi over 2. Okay, and then what's the sine of 3 pi over 2? Hopefully you know that. is -1, and that's -1/3. Okay, so when x was pi over 4, y was -1/3. Yes, when x is pi over 4, y is -1/3. A lot of people will not take the time to do that, but it's easy to make a mistake and do something wrong when you fill out your chart, so I really recommend you at least do one check like that, and you don't just assume that you have all the correct order pairs. All right, now remember we had a phase shift of pi over 2 to the left, and this is the graph of just, it looks like, see the sine curve here, the main one? It looks like it did, everything got shifted over, pi over 2 units. So this was kind of easy to see. And the amplitude was 1/3. Notice it is just up 1/3 and down 1/3. And the period you can see is in between 0 and 2 pi. So hopefully it all makes sense. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.